part D.4, Project 2, Formula Estimate for Overflow. In this part, we will use formula estimate, Fibonacci formula. So we know we have the Fibonacci formula. Yeah. Fibonacci. All right, yeah. With this formula, we can calculate the largest possible problem size that does not cause overflow. Yeah, that does not cause the overflow before the overflow happens. Yeah, so we want to get that number. All right. To do that, yeah, remember we use the long integers. Actually, for the long integer, we want to use unsigned long integer. The reason is we don't need to represent the sign, right? If you use a sign bit, you lose one bit representation because you need to use the first bit as the sign bit. Long, unsigned long, we can save that bit. So that is important for us. So here, with unsigned long integer, remember 8 bytes are used for long integer. 8 bytes without some bit. How about that? All right? Yeah. So we have 8 bytes without sign bit. How about that? All the bits can be used to represent a binary number. Yeah. So that number should be, that the maximum number should be, here I like to use a notation for it. Yeah. N max, capital N max. Little n max, we use it for another, the problem size representation. So this one, 2 to the 64, 8 bytes, 64 bits, minus 1. Yeah. That is the largest unsigned long integer number. Yeah. All right. Yeah, so in order to determine n, little n max, we have 2 methods. In this video, we look at the first one, method 1. Calculate this number directly without doing experiments. Yeah. So you can use formula of Fibonacci numbers in terms of golden ratios. Yeah. Then use math operations. Yeah. Next slide, I will give you the detail to do this calculation. So in your program, after you understand this method, you need to do that calculation. All right, so let us discuss the calculation part. Method 1, use the formula of the Fibonacci numbers. We know we have this formula. This is the formula. Yeah. Phi, the golden ratio, this number. Yeah. Now, let us do the estimate. First, the first thing, when you look at the formula, it is still pretty complicated, right? Yeah, if you work on that directly, it is too hard to get a relatively simple estimate. Yeah. So first, we want to simplify the formula. But when we simplify formula, let us look at the second term. The second term has the property. First, we know phi greater than 1, right? Yeah. So this number greater than 1. Yeah. Actually, it's 1.61 ... right? Greater than 1. So then we have 0 less than 1 over phi less than 1. Okay, yeah. So then this term plus or minus, we have 0 less than 1 over phi to the nth less than 1. Okay, yeah. So it is a small fraction. So very small fraction. All right. So then, now we do estimate in this way. Okay. We have phi to the nth minus this expression less than plus 1. How about that? Okay, yeah. Yeah. Then, so you can see after we use plus 1, much simpler, right? Yeah. So then the formula f sub n less than 1 over root 5 phi to the nth plus 1. How about that? Okay, yeah. Now, set up inequality. So we enlarge the Fibonacci number representation, enlarge a little bit. Yeah. After we enlarge it, we force, so this inequality, we force it. We force it less than capital N sub max. How about that? The one we use from the previous page, this number. Yeah. So you have this equality, right? Inequality. All right. So then let us simplify it. Phi to the nth less than root 5 times capital N max minus 1. How about that? All right. Yeah. Now it is the time to take a logarithm. Natural log. Yeah. Let us use natural log. N times natural log phi less than natural log root 5 n max minus 1. Okay? Yeah. Then n less than division all right, this division. How about that? Okay, yeah. With this inequality, we can see our n max. Our n, little n max, should satisfy this condition. Okay, yeah. So, what? Can we take floor function of right? Can we take that function? Right? Yeah, we take it. Yeah. So after you take this function, you get a, so this is a, we call it close estimate. How about that? Very close estimate, but it may not be the precise upper bound. It may not be very close, so we can guarantee it is very close, but may not be very precise because we use a lot of less than sign. Yeah. So many places we use less than sign. So there is a possibility our estimate may not be very precise, but you can see it should be very, very close. Yeah. So that's good enough for this project. This estimate is good enough. Yeah. But we have the second method. We will get precise upper bound, precise max upper bound. Yeah. All right. We use next video to talk about method number 2. That's the experiment-based method. Then it must be precise because we do experiment. So this is a formula-based method. Although we can get the estimate faster, but the disadvantage is it may not be precise. It is close, but may not be precise. All right, so let's stop right here.